Good evening, everyone. My name is Tad LaRock, and I'd like to welcome you back to another Tech Talk in our series sponsored by Codesmith, Jeeny, and Bractlet. Today, we have the pleasure of welcoming Ivan Del Fiero to give us a brief talk about design patterns. So without further ado, I'd like to pass it over to you, Ivan.
Thank you for the introduction, Tad. I'd first like to start by thanking Jeeny and Bractlet for sponsoring this Tech Talk. Let's dive into design patterns, working smarter so that we don't have to work harder. Design patterns. So what? Design patterns are concepts that offer proven solutions to common design problems. They encapsulate solutions to problems that software developers often encounter. Each pattern targets a specific recurring design problem. Design patterns provide guidelines for structuring code, organizing classes, and defining relationships. They also provide a structured approach to solving design problems, allowing us to solve challenges in a systematic and proven manner. There are three major categories of design patterns: creational patterns, structural patterns, and behavioral patterns. Creational design patterns deal with the process of object creation. To make them easier to remember, I've grouped patterns within a major category into subcategories based on some common characteristics. Here, we have creational patterns involving instantiation. The singleton pattern allows developers to ensure that a class has only one instance while providing a global access point to this instance. The prototype pattern allows us to copy existing objects without creating dependencies on the object classes. The singleton pattern is like having a unique key to a special lockbox. No matter how many times you ask for the key, you'll always get access to the same lockbox, ensuring that there's only one instance of that lockbox. Here, we see how the singleton design pattern ensures that there's only one instance of the store created. We expose a method, getStore, that creates a new store if it was originally undefined. Any succeeding calls of getStore results in returning the store that was instantiated. The prototype design pattern allows us to make copies of something cool we've already created, letting us easily create more of the same thing without starting from scratch. In this example, we can see how the prototype pattern allows us to create new objects by copying the properties and methods of a prototype. Player prototype serves as a prototype for creating player objects. It contains the name property and the say hello method. To create players, we use the new keyword to create new player objects with a name passed in as an argument. We also have patterns that involve object creation. They are the factory method pattern, which provides an interface for creating objects in a superclass, but allows the subclasses to alter the type of objects that will be created. The abstract factory pattern, which enables the creation of related object families without the need to specify their concrete classes, and the builder pattern, which simplifies the step-by-step construction of complex objects by producing different types and representations of an object using the same construction code. The factory design pattern is similar to a specialized workshop where you can order various items based on your needs, and the workshop produces those items without revealing the production details. In this example, we're using a simple function createChair as the factory to create different types of chairs. When you call the createChair function with a chair type argument, it returns a chair of the specified type. The abstract factory design pattern is like a furniture factory that produces entire room setups, creating chairs, tables, and other pieces. They match in style and materials, making it simple to furnish the space cohesively. Let's focus on how the furniture factory is able to create loosely related pieces of furniture like a Gothic chair, Gothic table, and Victorian desk. The furniture factory creator acts as our abstract factory, allowing us to create different types of furniture with different styles. We can make a variety of different types and styles of furniture simply by passing arguments into the furniture factory creator's make method. The builder design pattern is comparable to constructing a house with a step-by-step blueprint, where each construction worker focuses on a specific task, like building walls or installing windows, ensuring a well-organized and efficient building process. In this example, the builder pattern separates the construction of a house object from its representation. Different builder classes, basic house builder and fancy house builder, handle the construction process while creating different types of houses. The house director class coordinates the steps required to build a house. This approach allows us to create houses with varying configurations while maintaining a structured construction process. Structural design patterns focus on how classes and objects can be combined to create new structures or interfaces while keeping the system flexible, maintainable, and extensible. We can group structural patterns into class composition, object composition, and the proxy. Structural patterns involving class composition include the adapter pattern, which allows objects with incompatible interfaces to collaborate, and the decorator pattern, which facilitates the addition of new behaviors to a target object through a wrapper. The adapter design pattern is like a translator that converts information, in our case, from XML to JSON, allowing different systems to understand and work with each other's data formats. Here, the create XML to JSON converter function creates a simple XML to JSON converter object. This is our adaptee. The create XML to JSON adapter function creates an XML to JSON adapter object. It takes our adaptee as an argument and returns an object featuring a convert method that utilizes the adaptee's convert method. We can then use our adapter as the interface, hiding the adaptee interface from the client with no functional difference. The decorator design pattern is similar to adding layers of clothing, like wearing a cozy coat, to keep warm. Each layer can add additional features or traits while maintaining your overall style. Here, create person creates a person object with a where method. The add coat function, our decorator, will take a person as an argument and return a new person object with the enhanced where method that adds the wearing a coat to stay warm message. Here, we use the decorator pattern to decorate a person with a coat, giving them the ability to stay warm. Next up, we have structural patterns that involve object composition. These include the composite, in which objects are composed into tree-like structures, allowing developers to work with these structures as if they were individual objects. The bridge, which enables the division of a sizable class or a group of close related classes into two distinct hierarchies, abstraction and implementation. The flyweight, which facilitates the accommodation of additional objects into available memory by sharing common parts of state between multiple objects instead of keeping all of the data in each object, and the facade, which provides a simplified interface to a library, a framework, or any other complex set of classes. The composite design pattern is like organizing a contacts book, where we can have both individual contacts and groups of contacts. It lets us manage our contacts uniformly, whether you're dealing with one person or a whole group. Here, the individual contact class represents an individual contact. The contact group class represents a group of contacts. In the usage section, we create individual contacts like mom, dad, etc., and contact groups, parent group, Uncle Bob's family group, and all contacts. We can send messages to individuals, groups, or everyone. The composite pattern enables a uniform treatment of individuals and groups, facilitating the creation of a hierarchical structure for both entities. This approach streamlines the process of sending messages to each contact within the hierarchy. The bridge pattern resembles a remote control setup that detaches a button pressing from the physical devices, permitting device transitions without affecting the interaction approach. In this example, we look at how we can separate the implementation from the abstraction. We can create various devices using the create device function. Create switch generates a switch abstraction that produces switch functions, flip on and flip off, that delegate to the corresponding functions of the specified device. The flyweight design pattern is like a smart inventory management system where we keep a few shared items of the same type and modify them as needed. This saves space and helps manage a large variety of items efficiently. Create Equipment Flyweight is a flyweight factory that manages shared equipment configurations. The warehouse object represents a warehouse to manage available equipment. The hire employee function simulates hiring and managing employees. It uses the equipment flyweight to manage the equipment's shared state. When an employee is hired, the function checks if the required equipment is in stock. If not, it adds the equipment to the warehouse. The equipment is then assigned to the employee's workspace. When an employee leaves, their equipment is returned to the warehouse for storage until a new employee is hired. The facade design pattern is similar to a simple remote control for controlling a complex home theater system. It provides an easy way to perform multiple actions with a single button press, making it user-friendly and hiding the system's complexity. If you think about it, when you're going to watch a movie, there's so many steps to do. You have to turn on the DVD player, set up the projector, set up the surround system, adjust the lights. With the facade pattern, We can use the home theater facade class to encapsulate the complex interactions between the subsystems, providing a user-friendly interface for starting and ending the movie watching experience. The proxy design pattern is like having a trusted assistant who writes and delivers checks to transfer money from your account. They ensure that the process is secure and accurate, sparing you from handling the details yourself. Here, the create bank account function creates a bank account with an initial balance. The create checking proxy function creates a payment proxy that wraps around the bank account. It provides a write check method that checks if there are sufficient funds in the bank account and deducts the payment amount if possible. When we call the write check method on the proxy, it first checks the bank account balance. It then deducts the payment amount if sufficient funds are available. With that, the proxy pattern can be used to control and manage access to a real subject, bank account, and additional behavior, like writing a check before performing an action, making a payment. Finally, we have behavioral patterns. These can be broken up into communication patterns, state patterns, and data patterns. Communication patterns are concerned with how objects communicate and interact with each other. They are composed of the chain of responsibility pattern, which lets you pass requests along a chain of handlers. When a handler receives a request, each handler decides either to process the request or pass it to the next handler in the chain. The command pattern, which turns requests into a standalone object that contain all information about the request, allowing us to pass request as an argument, delay or queue a request execution, or support undoable operations. The mediator pattern lets us reduce chaotic dependencies between objects by restricting direct communication between the objects, forcing them to collaborate only through a mediator. And the observer pattern, which allows the definition of a subscription mechanism to notify multiple objects about any events that happen to the object that they're observing. The chain of responsibility design pattern is like passing a message down a line of people, where each person can decide if they can handle the message or pass it to the next person, ensuring that the message is taken care of by the right person eventually. In this example, each person in the chain, director, manager, and supervisor, has a handle request function that either approves the request or passes it to the next person in the chain. The chain starts with the director, followed by the manager, and finally the supervisor. When a message is passed down the chain, each person checks if they can handle the request. If they can, they handle it. Otherwise, they pass it to the next person. If the request reaches the end of the chain and no one can handle it, the request is not approved. The command design pattern is akin to ordering food in a restaurant. You give instructions to the waiter who takes your order and serves a meal, letting you separate the action from the requester and enabling flexibility in handling different orders. In this example, we have a cook that can prepare a few dishes and a waiter who takes orders from customers and returns command objects representing the orders. The place order function uses the waiter to retrieve the appropriate command object based on the order and then executes the command so that the cook prepares the appropriate dish. The mediator design pattern is like a meeting organizer that helps different people talk to each other effectively. It centralizes communication, making sure everyone is on the same page without them needing to directly interact. In this example, the meeting organizer acts as a mediator, facilitating communication between participants. Each participant that was created with the participant constructor can send messages to others through the mediator. The observer pattern is similar to tuning into a radio station where you listen for updates. When the station broadcasts new information, you're instantly informed without needing to keep checking, keeping you connected to the latest news or music. In the following example, Observer 1, Observer 2, and Observer 3 are subscribed to an event instance. When that event fires, each observer's respective trigger message is displayed. After unsubscribing Observer 1 and Observer 3, firing the event again only triggers Observer 2, illustrating the observer patterns mechanism for handling multiple observers and their notifications. The state design patterns are architectural patterns that provide solutions for managing the state of an application in a structured and maintainable way. They include the state pattern, which lets an object alter its behavior when its internal state changes, and the strategy pattern, which lets us define a family of algorithms, put each of them into a separate class, and make their objects interchangeable. The state design pattern is like changing the behavior of a machine based on its current condition. It helps the machines switch between different modes or actions smoothly, adapting its behavior as needed. In this example, playing state and pause state represent different states of the game. The game holds the current state and provides methods for playing and pausing the game. The game transitions between playing and pause states based on the current state. Here we can see how playing and pausing results in different responses based on the current state. The strategy design patterns like having different ways for ducks to quack. Depending on the type of duck, they can make various sounds, and you can choose the quacking style that suits each duck without changing how they look or swim. So here we have a duck constructor and we create two instances, a mallard duck and a rubber duck. But wait a minute, I'm pretty sure rubber ducks don't quack. We solve that problem by using the strategy design pattern so that there are different quacking behaviors for different types of ducks. The duck object's quack method serves as an interface which can be dynamically set to either duck quacking or duck no quacking based on the Boolean parameter passed. This allows different duck instances like the mallard duck and rubber duck to have distinct quacking behavior. Data patterns are behavioral design patterns that involve managing and manipulating data structures and collections efficiently. These include the iterator pattern, which lets us traverse elements of a collection without exposing its underlying representation, and the memento pattern, which lets us save and restore the previous state of an object without revealing the details of its implementation. The iterator design pattern is like a tour guide that helps you explore a collection of items step by step, letting you access each item without needing to know the underlying structure of the collection. The iterator pattern is implemented through our iterator constructor. It takes an array of items as an argument and maintains an index to keep track of the current position. The hasNext method checks if there are more items to iterate over, while the next method returns the next item and advances the index. The memento design pattern is similar to taking snapshots of something important, like saving your progress in a game. This lets us return to these snapshots later if we want to restore a state to a specific point. In this example, the text editor acts as the originator. The history acts as the caretaker responsible for storing and managing snapshot. Then we set the text editor's content, create snapshots, edit content, and save new snapshots. We later restore the content from the snapshots in reverse order using the history, displaying the power of the memento pattern. With all that, please remember, design patterns will cramp your style. No, I'm sorry. CRMP was the best I got. MCPR didn't have the same zing. There's a lot happening in this slide. So in short, design patterns will enhance collaboration, allow code consistency and reusability, improve code base maintainability, and allow for faster problem solving. So when should we use design patterns? Consider factors such as problem complexity. Utilize design patterns to offer structured methodology for addressing complex problems. Maintainability. Design patterns often enhance organization and readability, making it easier for developers to understand and modify code. And feature flexibility. Design patterns can enhance your code's flexibility, making it easier to accommodate changes and additions. Here are some common mistakes to avoid. Don't overuse patterns. Applying design patterns excessively can result in complicating code comprehension and maintenance. Understand the patterns that you use. Using a design pattern in the wrong context or applying incorrectly can lead to convoluted code that's difficult to maintain and understand. And don't ignore your project's context. Design pattern tools, not one size fits all solution. Ignoring your project's context can lead to mismatched patterns and inefficient solutions. Here are the works that I have cited. I have to apologize for going a little long. As such, I don't think we have time for questions. However, feel free to connect with me on LinkedIn or GitHub. Thank you for listening.
Thank you so much for that informative talk, Ivan, and thank you everyone for coming out tonight. We'll see you at the next one.